in today's video, we're going to be doing something a little bit different. Up until now, I have been posting mostly shoe repair videos, but whilst that does make up a major part of our business, it's not the only thing that we do. I also do a lot of general leather repairs, and I occasionally get asked to make things for customers. Plus, if I haven't already done it, I do also plan to add some handmade leather items to the website over the course of the coming months. With that in mind, I find myself burnishing the edges of leather very often. And if it's anything thinner than the sole of a shoe, I have had to do that by hand. Given that I am going to end up doing more of this and finishing things by hand is a slow process, I figured it would make sense to manufacture a tool to speed that process up. This is my shoe finishing machine. This covers a whole bunch of tasks from burnishing, buffing, sanding, then there's a finer grit, smaller sanding wheel, and there's also a little sander up here. On this side of the machine, you've got a whole selection of tools that you can fit to this. They've got a bayonet fitting tapered shaft that's driven by the machine independently rather than by these belts. And that allows you to fit a selection of very task-specific tools. So you've got little sanders, little sanding cones for doing heels. You might have cutters, and I think I've got a couple of attachments for shaping wooden lasts, although I never actually used those. So the cutters look like this. And while I do actually use this particular one, which I think is for heels specifically, but I use that a lot for trimming up leather soles, I actually don't use the cutters very often. So these attachments consist of a bayonet fitting sleeve with a left-hand threaded screw, and then the cutter itself is like that, but you're left with this piece. So my plan is to make a little wooden burnishing wheel that will fit over this sleeve. As you can see, there's no keyway on this, so it can rotate on the shaft, but that left-hand thread means that if this cutter was to meet resistance, it would be doing up that screw because of the left-hand thread. So it spins this way, but any resistance or forces in the opposite direction would be tightening up this screw. When I set out to make this part, I anticipated it being both quick and easy to do, seeing as it is just a wooden disc fitted onto a shaft. I didn't have to make anything clever, just a wooden disc. However, it was not quick or easy and turned out to just be a series of lessons that I hope I remember and can apply in the future. So the plan was, and as you will have just seen, to rough cut the outside on the bandsaw, drill out the centre of this so that I could mount it on a piece of threaded bar, which would act as a temporary arbor, mount that into the 3-jaw chuck, turn the outside diameter, and then flip the jaws on this chuck and hold the outside perimeter whilst I machine the inside. However, the first of the lessons is coming up, and it turns out that for the 8 years that I've owned this lathe, I've never attempted to turn the jaws around on this 3-jaw chuck. And it turns out they're not actually reversible. So this was a lesson learned. The second lesson, that bit in the collet chuck there is not set long enough. So when I attempt to use this machine in a second, the collet chuck is going to crash into the piece of wood and pull itself across, ruining my part. So you will notice that towards the bottom of this cut, or towards the bottom of the disc, the wood is slightly burnt. I am purposefully running the machine a little on the slow side because I don't want to have to do too much finishing to the outside diameter of this. So by running a little bit slow, it should give me a very smooth cut. But I do think it's probably overheated the cutter, and towards the bottom of that, it went dull. So with that done, you will have noticed that I ended up using a CNC machine. So the chuck on my lathe is a 3-jaw chuck that I, for whatever reason, thought had reversible jaws, which would allow me to grip the outside perimeter of this wooden disc. So I started roughing it on the bandsaw, and then I took it over to the lathe, and the plan was to cut the outside diameter to the finished dimension, and then flip the jaws on the chuck, hold the outside perimeter of this, and then work on the inside diameter to get it to match the shaft on here. However, without reversible jaws, there was no way of doing that without changing the chuck to the 4-jaw that I have. However, that's quite a lot of work, and I just thought it was going to be faster to get a CNC machine. However, I also crashed the CNC machine and broke the bit. I'm fairly certain that that came about because I didn't have the bit set long enough, and the collet chuck itself actually touched the surface of the material and pulled itself across into it. So yeah, that crashed. So we're on to this, and now I need to put a groove into the outside perimeter of this that the leather will ride inside of. I'm going to do that groove at 4.5 mil, which means I do need to grind a cutter to go into the lathe at 4.5 mil. I could potentially have done this in the CNC machine as well if I had a 4.5 millimeter cutter. I don't have a 4th axis, so it would have need to be a cutter in a similar shape to this to run around the perimeter of it. I don't have any of that, so I'm going to have to do it on the lathe. So, having tried it out, I've discovered that it actually spins too fast. And it burns the leather a little bit. So, given that I can't reduce the speed of the machine, the only way that I can reduce the surface speed of the actual burnisher is to reduce the outside diameter. Thankfully, having done that on the CNC machine, it is just a simple adjustment of the program that it's running, so I will now reduce the diameter and have another go. As easy as that. Why I said as easy as that, I don't know, because from past experience, nothing is ever as easy as that. In changing the diameter, it changed the toolpath and for whatever reason removed the hold down tags, which was stopping this part from coming loose. So around the perimeter of that cut, there was a series of steps that would hold that piece steady that you would cut through when you removed it. However, in changing that one dimension, it removed that part of my toolpath, which meant that the piece came loose and rattled around and ruined the outside diameter. So while the CNC machine is cutting out a new wooden disc for me, I thought I'd quickly cover the geometry of that cutter that I'm going to use in the lathe. So my piece of high-speed steel tool cutting blank, which looks like this, I need to grind so that I've got relief, so the front cutting edge, the bit that's going to contact the wood, needs to be the only part that contacts the wood. Everything behind that front cutting surface needs to be narrower so that it's not rubbing on the material as I drive it deeper into the piece of wood. So I have to grind the faces behind back so that it's sort of a dovetail shape with the radius on the outside, keeping that front cutting area at 3.5 mil. And then, radius that so that it gives me the groove in the bottom of the cut. Also, if you were looking at the cutter from the side on like that, I need to cut relief here so that the bottom half of my cutting tool is not rubbing against the wood either. There's loads of ways for cutting grinders, and there could be a potential that I would have to remove some material from here to give me more of a gouge, but I'm hoping that by leaving it as somewhat of a scraper that it'll give me a cleaner cut, and then I won't need to do so much cleaning up afterwards of that groove, and it should just be nice and smooth in there. That's the cutter ground. I have already used it to do that first disc, so I know that this all worked, but there you go. Difficult to see, but that is a slight dovetail shape so that the sides don't rub inside the groove. So let's groove the next one. So that is everything done. I have already run a couple pieces of leather through here just to ensure that it was nice and smooth and that it wasn't going to burn anything. But as you can see, a piece of leather, freshly cut, and the edges are just taken off using a leather beveling tool. I'm just going to put a little bit of edging compound on there. And then lovely. So I'm going to call that a success. I do now have a burnishing tool to go onto the side of my shoe finishing machine, and whilst I do normally do shoe videos, and this was very different, if you did enjoy watching this, I would like for you to let me know, as I have just acquired a Adler 105 subclass 8 sewing machine to help me out with a couple of the other projects that I've got going on at the moment. However, the foot that that machine has come with, I think, is probably wrong, as it doesn't work quite as it should. So I need to get a new foot. I've had a good look around and I can't find one. So I think in order to get what I need, I'm probably going to have to make it. The best way I can think to make a sewing machine foot is lost wax casting, which I've never done before, so I thought I would have a go at that too. So if you would like to see that process as well, let me know and I'll film that. See you in the next one.